There are universities and a competitive business environment with hundreds of R&D companies, thousands of people employed in science, and millions of euros spent on research each year. That's why more than 1,400 employees from roughly 45 countries do science at SciTech. Here, they have the power to make our world a safer, more efficient, and more sustainable place to live. SciTech is headquartered in Brno, Czech Republic, the birthplace of Gregor Mendel and a global hub for electron microscopy. Situated in the heart of Europe with an excellent quality of living, Brno is more affordable than other EU cities, allowing for a comfortable way of life in a city that ranks among the best and safest in the world. Moreover, Brno is known as the European Silicon Valley. There are universities and a competitive business environment with hundreds of R&D companies, thousands of people employed in science, and millions of euros spent on research each year. That's why more than 1,400 employees from roughly 45 countries do science at SciTech. Here, they have the power to make our world a safer, more efficient, and more sustainable place to live.
The arrival of Industry 4.0 means production is becoming increasingly automated and digitalized. Although companies often have their own proprietary solutions, they're typically not standardized, so manufacturing continues to take place in independent and unconnected units of various size. 2 Czech and 2 German research institutes have joined forces in the creation of a project for new intelligent, secure, and sophisticated solutions for distributed manufacturing in the Industry 4.0 environment. The collective effort led to the establishment of RICAIP, the Research and Innovation Center on Advanced Industrial Production. RICAIP primarily focuses on developing an entirely new concept of multi-site production in which each machine has a digital twin that reflects its characteristics and communicates with other digital twins. Digital twins aren't used only for individual machines. Entire manufacturing units and other entities involved in production can have them too. This makes it possible to simulate the entire production process and reciprocal communication, thus significantly accelerating production preparation while eliminating the occurrence of errors. Thanks to artificial intelligence, manufacturing units are able to share knowledge with one another, and the system can optimize production and respond quickly to constantly changing environments. Moreover, the combination of virtual reality and augmented reality allows additional virtual devices to be introduced to the production process and tested prior to their physical implementation in shop floor. Likewise, potential new suppliers can enter the process, as well as the customer, who can configure the parameters of the required product and make other changes if necessary, even at the last minute. These are the principles upon which future automated multi-site production networks will be built, and upon which they will accelerate the implementation of new manufacturing processes, reduce production costs, and make it easier for companies to enter the market and value chains. Production as a service and shared resources. This is the future of industrial manufacturing.
SciTech is headquartered in Brno, Czech Republic, the birthplace of Gregor Mendel and a global hub for electron microscopy. Situated in the heart of Europe with an excellent quality of living, Brno is more affordable than other EU cities, allowing for a comfortable way of life in a city that ranks among the best and safest in the world. Moreover, Brno is known as the European Silicon Valley. There are universities and a competitive business environment with hundreds of R&D companies, thousands of people employed in science, and millions of euros spent on research each year. That's why more than 1,400 employees from roughly 45 countries do science at SciTech. Here, they have the power to make our world a safer, more efficient, and more sustainable place to live. SciTech is headquartered in Brno, Czech Republic, the birthplace of Gregor Mendel and a global hub for electron microscopy. Situated in the heart of Europe with an excellent quality of living, Brno is more affordable than other EU cities, allowing for a comfortable way of life in a city that ranks among the best and safest in the world. Moreover, Brno is known as the European Silicon Valley. There are universities and a competitive business environment with hundreds of R&D companies, thousands of people employed in science, and millions of euros spent on research each year. That's why more than 1,400 employees from roughly 45 countries do science at SciTech. Here, they have the power to make our world a safer, more efficient, and more sustainable place to live. SciTech is headquartered in Brno, Czech Republic, the birthplace of Gregor Mendel and a global hub for electron microscopy. Situated in the heart of Europe with an excellent quality of living, Brno is more affordable than other EU cities, allowing for a comfortable way of life in a city that ranks among the best and safest in the world. Moreover, Brno is known as the European Silicon Valley. There are universities and a competitive business environment with hundreds of R&D companies, thousands of people employed in science, and millions of euros spent on research each year. That's why more than 1,400 employees from roughly 45 countries do science at SciTech. Here, they have the power to make our world a safer, more efficient, and more sustainable place to live. SciTech is headquartered in Brno.
And welcome to the first 22. The better future relies on science. Science tries to come up with solutions for sustainability, health, or
help to light a bulb to get to the moon or to split the atom, and we seek their help also to overcome a lot of challenges
such as climate crisis. But no scientific success could be imaginable without honesty, responsibility, fairness, and accountability.
These are the values that define the research integrity. And this is also what we are going to talk about today. We will address ethical principles that must be respected in all default society to be able to trust research activities and the outcomes of scientific work. Our three inspiring speakers that are ready for today, that are both from the Czech Republic and abroad, will talk about European context of research integrity topics, how to increase trust in science by preventing fabrication, falsification and plagiarism, and ethical questions associated with technology transfer. We are very happy to have here Pere Pușdominic, Tomas Voltinik and Marty Clement to share their insights with us. But before we start, I would like to remind the platform that we are part of. You have probably heard about RICAIP project before, but if you haven't, we have here a person that will welcome us today at the seminar. And it is the RICAIP project coordinator at SciTech BUT, Professor Pavel Václavek, who is at the same time coordinator of research area Industrial Cybernetics, Instrumentation and Systems Integration, and team leader of two research groups, Cybernetics and Robotics and Smart Factory at SciTech BUT. So, Professor, you can welcome us.
Welcome to the seminar organized by RICAIP Center. Today we will talk about ethics in science, but at the beginning I would like to say a couple of words about RICAIP, what is RICAIP doing and what we are doing here in Brno. So RICAIP project is dealing with technologies for Industry 4.0. So we do research in the field of automation, big data, cloud computing, autonomous systems, Internet of Things, and use and collection of data. And putting all together to prepare technologies for factories for a future where massive automation will be used to be able to do most production works nearly without human work, and to allow people to do something more productive than manual work. If we look to the research topics within this center, we deal with topics like digital twins, interaction of human, machines, robots. We deal with distributed production systems, and also with technologies for sensing, actuators, and control in distributed production processes. And of course, as we are a university, we pay a lot of attention to topics related to education and to development of human resources for labor market. Here in Brno, oh, it was somehow fast. So here in Brno, we are going together with partners within RICAIP who are CIRC in Prague and DFKI and Zima from Germany to build one of the test beds for Industry 4.0, which will be part of distributed testing environment where we'll be both on our side and also for our partners from other institutes and industry, where we'll be able to test new technologies for Industry 4.0. So why we are now talking about ethics in this context? While RICAIP is industry-oriented, of course, we do a lot of research, and in this area, we deal with topics like publishing results of research, where we need to consider how to properly share information, reuse results of other authors, other teams. Sometimes this is not so straightforward because publication culture in different scientific fields can differ very significantly, and it is question how to do such publishing in a right way. Also, we need to share research data, and here topics like how can we trust to share data, how can we be sure that all the ethical aspects when using such data were fulfilled, how can we repeat experiments and to be able to prove that we really did such experiments. And also, while this is the last point on this slide, but definitely not the least topic, ethic topics related to commercial use of results of academic research, leading to question how to do fair business using our results. So I guess that there will be much more interesting topics in this seminar. I hope that you will enjoy it and learn something new, how to connect view on ethics and view on research even in the industry-oriented area. So thank you for attention, and now we can continue with discussions on ethics topics.
Thank you very much, Professor, for the introduction. And as we heard today, we will listen to 3 personalities that are engaged with the topic of ethics in science. And we would like also to encourage you, those who watch us, to participate. If you have a question or comment, we have Mentimeter ready for you. You got the link in the email invitation, and you can go on the link, and there is a bar where you can add question or comment that you would like to ask or to add to what is said here inside. You have maximum 250 signs, but if this is not enough for you, you can just split the question
into more questions, and I will ask for you. We would also like to inform you that the whole session is being recorded, and it will be available and put online. So, and the first speaker is getting ready, but before he starts, I would like to add some background. Pere Puigdomènech has a degree in physics from the University of Barcelona and a doctorate in biological sciences from the Autonomous University of Barcelona. His current field of research is plant molecular biology and genomics. He has published 150 scientific articles in refereed journals and books, 2 patents, 5 books on popular science and scientific fiction, and supervised 18 PhD theses. He has published more than 500 articles on science in renowned Spanish as well as international scientific journals. Pere has been a member of the scientific staff of the Spanish Research Council and presently serves as research professor in its Center for Research in Agricultural Genomics in Barcelona. This all makes him a very experienced scientist, but his activities, no matter how admirable they are not the main reason why he is here, because besides these activities, he is also a board member at all European academies. This Federation of Academies of Sciences and Humanities is independent from political, religious, and commercial interests. It was founded in 1994 and brings together more than 50 academies of sciences and learned societies from over 40 member countries of the Council of Europe. Its mission includes facilitating the collaboration between academies, fostering excellence of research, representing the European Academy's position to the European authorities, and contributing to the improvement of the framework conditions for science and research. So, what is the European Code of Conduct for Research Integrity? What guidelines does it provide, and how can it help the European research institutes? These are the questions for our very first speaker, Pere Puigdomènech.
Thank you very much. Thank you very much for your invitation. Indeed, I will try to explain with the place of ethics in European research area, and including, of course, the European Code of Conduct that we have been drafted in ALEA. I will try to share a screen. So, can you see it? Yes, it's okay?
Yes, we can see the screen.
Okay, excellent. Then this is the subject. And just to introduce you the importance of this subject, you will see that if you look at the program guide of the present Horizon Europe project, you will see the number of table of contents, number different numbers, and in 12 you see ethics and integrity. So this is an important issue when you want to apply to European grants, and there is a guide to complete what is called the ethics self-assessment. What kind of questions are there in these guidelines? You see, you have to answer questions about whether you use human embryonic stem cells. I will just discuss a bit this question: humans, human cells, personal data, animals, if you are collaborating. So a number of issues that are considered part of the need to answer when you are applying European grants. For instance, you have many questions, but for instance, environmental health, which are also quite important, and even questions like consumer safety. If you have any during your work, you have to deal with questions with health and safety of work.
Mr. Puigdomènech, we still see the first slide.
No, I am passing.
Still the first slide.
No, I have in my screen, I am passing the, so I don't know what is happening. Ask your technical issue, because from here, from my computer, I am passing very happily the different questions. What do you see at this moment?
I see the research integrity in the European context. And now it switched to the second slide.
Okay, good.
Now it switched. Good.
Is European grants.
Yes.
And you see here ethics and integrity. ethics, you have how to complete ethics self-assessment. You have a number of questions that I just said. And for instance, in European grants, you have, when you have some identifying issues which may be complex, and all these questions are generally quite complex. And here you see that when you look at that, at the end, there is the light, in the light of European Code of Conduct for Research Integrity that I will talk. Why are we asked to do that? You see, the origin of these questions may go to the Second World War, when bioethics was raised in the light of the type of experiments that were done during the war. And the first code of good practices in bioethics was the Code of Nuremberg. And then already there in the court of the Nuremberg, some aspects on how to deal with research regarding, for instance, human subjects were highlighted. You cannot do experiments without consent of the persons with a benefit. So there are a number of laws that mostly at this moment there are in European and national laws. One of the questions that you've seen in the guideline is, for instance, European research on stem cells from human embryos. And in Europe, that may be complex. It's an example of the complexities in European research, because there are countries that where research is allowed with conditions, there are countries where no research is conditioned. So what European Union should do. And this is an example of how ethics thinking, ethics reflection, may be important for science. To answer this question, the European Commission asked, which is called European Group of Ethics, already in 2007. So the Group of Ethics on Science, which is a group of philosophers, scientists, jurists that advises the European Commission. This is, you see, a number of people. I have been a member from a number of years. And there are a number of questions that are addressed to this group of reflection, you see, new developments in agriculture, nanomedicine, technology. So different European countries have different cultural traditions, different economic implications. So what was the conclusion of thinking of how human stem cells are there? You see, for instance, the attitudes of different countries is very different. Some countries are very open in the use of these cells, like UK or Spain, while other countries are reluctant, like Austria or Poland, for instance. So the recommendations of the European Group of Ethics that are now in force, so is that you have to, European Union can fund this type of research, but not in countries where this is forbidden, but you can find that in other countries. And to a number of recommendations of minimizing the use, of maximizing other alternatives. So this is the kind of thinking that allows us to go ahead when there is some kind of ethics questions. But we have other requirements, for instance, animals, the use of animals. You see, we have a directive on the protection of animals used for scientific purposes, based on the 3 Rs, replacement, reduction, refinement. And we have animal experimentation committees. It's another example of regulations. Or, for instance, genetic modified organisms. When you think that you can put, for instance, some genetic modified plant on the field, there is also a directive that regulates this kind of experiments. So, why ethics in research? So we have different levels of ethics. The one that I just explained you is compliance with existing regulations. For instance, human subjects and materials, but increasingly data. Data have to be increasingly regulated. for instance, data on persons, privacy protection, data on us. This is very big issue at this moment. Animals, environmental, labor laws, and many other aspects. So this is one aspect of ethics and research. A different aspect of ethics and research is advising public. I will pass very fast on that. And here we have conflicts of interest. For scientists, we can be working in a specific subject. We may be collaborating with industries, which is very important in our countries. But at the same time, we may ask to advise public bodies on pharmacological products, on different products, on environmental questions. Then research integrity, the second half of my talk will be on that. And then participation in public debates. At this moment in Europe, for instance, we have a big debate on genome editing, for instance, in humans, in animals, in plants. So how we have to take part in these debates. All these are typical ethical issues. Conflicts of interest is very clear. We have, I will put you two examples. One is the biomedical research. In Europe, medical treatments and medical products are done by the European Medical Agency. And there has been a number of conflicts that they are very sensitive for our society. So there are a number of rules. Are you, for instance, for a scientist, we are asked, are you funded by some industries? There are a number of questions. For instance, the European Medicines Agency has a number of very clear definitions on what conflicts of interest says. For instance, employment of company, consultancy, all these questions. We have to be well aware that this is very sensitive for our society. How European Medicine Agency deals with, there is a declaration, so it is important of procedures and procedures to deal with that. The same thing, for instance, in EFSA. EFSA is the authority of food safety. It deals also with very important questions about safety of food, on additives, and many other questions, with GMOs in particular. For instance, GMOs, working with plant genomics. I have been a member of the panel of GMOs, for instance, which is in the center, you see. When approving some of these modified plants, the risk assessment opinion, which is a scientific opinion, is in the center. But this is a very complex issue, you see. It's a very complex and expensive aspect, and there are people who are against all these questions. So the chairman of this panel has been once sent a bomb in Parma. So you see, it's a very contentious and complex issue. So also just passing very, very quick, we have also some conflicts of interest in choosing research subjects. Collaboration with industries is important, but there is also, especially for public scientists, what is the common good. And so here we have also quite a number of complex issues that we can see. For instance, for complex, we are asked to always think about sustainable development goals, for instance. So it is, so I mean, those you see are complex ethical issues, and I will now go specifically towards research integrity, which is one of the subjects of this meeting. So why research integrity is important for us? Research integrity is important because credibility of science relies on the quality and reproducibility of results. If we are not publishing our results, if not making them public, scientific results are useless. We keep the results for ourselves, but these results have to have the adequate quality and in particular have to be reproducible. This is one of the conditions for publications. For decisions, there are a number of codes of good scientific practices. This is relatively complex because you see, as in this table, it shows that from error to fraud, there are a lot of gray areas. You, of course, as anyone, scientist, in our practice, we may deal with errors. We can make mistakes. And we have to accept that these things, for instance, our observations may be wrong due to technical issues or because it was not well designed at the beginning. But you see at the end, there is what you call fabrication. Some people at some point may publish, just say to publish, results which have been fabricated. This is something that is completely unacceptable for science, of course, because you are dealing with a completely an activity just against the practice of science. But between error and fraud, you see there are a number of different species. We will discuss that. And some aspects may be not intentional. You may make a mistake that you are not aware of that at the beginning, or it may be intentional. So all these aspects can be, and you see in the middle, we have from wrong observations that may be non-intentional error to wrong analysis and declare conflicts of interest. We just talk about that. The conflict of interest is very important now. When you publish, you have to put in the acknowledgements exactly how the work has been funded, who is in care of that, because of course you rely on this funding for your work. Publication bias. We will discuss a bit the question of publications because this is one of the main source of conflicts. Undeserved authorship, which is another good example. Suppressing data. You can be, in your publication, you may choose to show part of your data, not all of them, and that may create different types of data. And then the most typical example of misconduct, which is plagiarism, falsification of data, and fabrication of data. Those are the most well-analyzed type of fraud in science. So to deal with that, in ALEA and in the European Science Foundation, already in 2010, we published what is called the European Code of Conduct for Research Integrity. This is it's available through internet, if you like. It's a relatively complex document that tries to highlight, to define which are the principles that are basing scientific integrity. And these principles include honesty in communication, reliability, objectivity, impartiality, openness and accessibility, duty of care for everything, for subjects, for persons, for everything, fairness in providing reference, responsibility. So a number of questions which for a normal practice of scientists, it may seem something normal. We know that is our day-to-day way, but I mean, the codes try to define and to make it explicit. So in the way, especially for the training young scientists, but also for seniors that are those responsible of research are important. And also it defines misconduct. Here you see there's also the description of this fabrication, falsification, or plagiarism, but other aspects. For instance, one other form of misconduct is, it says here, failure to meet clear ethical and legal requirements. This is what we say at the beginning. It's what the European projects ask for, that you declare, that you are aware, that you are working in a legal framework with human subjects, with animals, with environment, with a number of aspects, and that you know that you have to comply with that. This is one of the ethical requirements that they are present now in many forms when you apply for grants in Europe, in private foundations, in many other aspects. And there, as it's case here, minor misconducts that may not lead to formal investigations, but they may be very damaging. The number of papers that have some minor aspects of bad practices, it has been analyzed. It's complicated, but some people say that more than 30% of papers published have some kind of misconduct, even if it's minor. This is a very discussed question. The question is whether the problem is increasing. One of the ways to measure this question is the number of retractions. When a paper has an important problem in the data, in the interpretation, in the way it has been doing, very often journals are asked to retract the paper. And this, as you say, this is very damaging for the persons who have been working on that, especially for junior persons. It's very damaging for institutions, for everyone. But the number of retractions have been rising. There is also a discussion here whether this is because people are increasingly aware of the problem, and for these reasons we will just discuss it is more people who are analyzing papers for its consistency, and then the number of retractions are increasing, or people think that this is due to the pressure. I mean, scientists are asked to produce, they are asked to publish in high impact paper journals, and that may be even their own promotion, even their own salary may depend on that. So this is that makes that in some cases, especially in some countries, this makes that scientists to find some shortcuts and try to publish fast and maybe in an improper way. So there is discussion on this matter. This is a discussion: is there really a reproducibility crisis? This is a matter that has been especially discussed from the industrial sectors, because they say that when they try to reproduce data that have been published, especially in the biomedical field, they cannot reproduce. And this, of course, is extremely damaging, because not only for reputation, but also, of course, for the progress, especially if you want to look for new pharmacological products, new treatments that may be specifically very damaging. For retractions, I can advise you to go to a website which is called Retraction Watch. Every day they publish the papers that have been, a selection of papers that have been retracted, and you can look at what kind of effects that has. There is another website, it's called PubPeer, that you can also enter. Every day 10, 20, 30 papers are denounced, and there are denunciation that this is anonymous. You can enter this and you can say, I've seen this paper, this figure has been fabricated, and then the authors may respond or not, and they may inform the journals. So if you go there, you will see that the number of the scrutiny that papers are being followed, it's very high, and that may also have an effect on our scientific career. And finally, I put this publications ethics organization. This is an organization of publishers, of scientific publishers. Here, if you are interested, you will find how to deal with these questions, the ways that papers have to be prepared, the limits. Of course, for instance, figures, as we'll see, figures, now when you publish something, you have to prepare, of course, your data. And of course, this is necessary, but you have to keep the originals. Now more and more, you are asked to keep the originals public or in reservoirs that you can use. So, I mean, all this, you can go and see what is happening. Appear, for instance, that, I mean, there is a list of papers of people who are saying, you see, in this paper, this question has been manipulated. And so this is quite important. There are now softwares for plagiarism. Plagiarism can be detected. Many journals are using them. Of course, this is very damaging. If you use the text or the ideas of someone, you have to refer for that. It's part of our scientific work. And figures, I mean, what it says here, assessing what is acceptable. So this is important, especially for young people, that we are aware that the figures have to be prepared, but some things are acceptable, some things are not acceptable. And especially you have to be transparent of what you have been doing, because these figures are important for results that you are using. Open access is another big discussion at this moment. Of course, we are going to open research. There is also maybe a conflict when you are working with industries, for instance. So there are a number of challenges, as it says here: selectivity, the cost, the recognition, intellectual property, a number of challenges which are complex. And there are some, of course, in this situation, there are predatory journals. There are journals where you can publish whenever you like. There is no scrutiny, and you just have to pay. This is also quite damaging. And there are paper factories. It has been shown that in some countries you just want to pay $1,000 and you get a paper published without your work. So this is also something which is damaging situation. In COVID-19, there has been discussion. The number of papers that have appeared during the last 2 years is enormous. And there is discussion whether there is an alarming and exceptional high rate of retraction. Some people think that it has been a number of papers have been published very fast and without proper controls. Some other people think they're not. So this is an example of this happening. I am belonging to the Spanish Research Council. We have a code of conduct. And for instance, what kind of conflicts appear we have an ethics committee. I was the chairman during 4 years, and you see, we have every year a number of conflicts that appear to these ethics committees that exist in different countries. For instance, you can have here an example: access to facilities, plagiarism, conflicts between scientists for authorships. This is very, very normal. Questions about the curriculum. You see, this is people have to be well aware that curriculum is an essential document for science. The concerns about articles, a number of questions. In Europe, we have a network of European research integrity officers in different countries. Of course, the legal framework is different in different countries, and how to deal with these questions is different. And these kind of networks are important to check how things are being analyzed in different countries. In the States, that was the first one, the Office of Research Integrity of the Department of Health, for NIH. It has been very active, and in the States, this may be dealing with the office every year has a number of cases that they analyze, and if they find guilty, they may have even juridical consequences, or they have to negotiate some penalties to these people, right? All these things are open in the States. You can go there and to see what is happening in the States, that they are working in these questions for more than 40 years. So what is the European Code of Conduct of Research Integrity? You've seen that European Commission refers to this code. Now, when you apply for a European grant, you have to be acknowledged that you know that this code of conduct exists, and the conditions that are presented here are going to be followed by your institution. What are the principles? This code starts with the principles that are essential for scientific activities. Reliability in ensuring the quality of research is what we have been saying. Honesty in developing everything, including reviewer, reporting, communicating. Respect for colleagues, research participants, for all, even for the environment, and accountability for the research. You have to be accountable for its management, for training, for all these questions. What are the good in the code? There are good research practices in different aspects. In the research environment, in training, supervision, and mentoring, this is an essential point. In all scientific institute, in the research procedures, safeguards, data practice and management, this is increasingly important in all our work. Collaborative working, this is a complex issue because you may very often collaborate with people from different countries that may have different environments, or even with different disciplines. And different disciplines have different ways of dealing with data, for analyzing data. And it may be quite complex. Publication and dissemination, we have been discussing. Review and evaluation and editing is also absolutely the key of these matters. Training, supervision, I mean, the code, as it says here, there's emphasis on training in research, design, and methodology. This is clear the key of the question. I mean, in our research institutions, we have senior people, we have technicians, we have junior scientists, and the relation with all these things may be complex. What is supervising the duties of everyone? So here it says that all people will have to undertake training in research. Research procedures, in the code, there are revised, the reduce duplication, research waste, the obligation of publishing. All these questions are in the code. Safeguards, for instance, trying not to discriminate in different types of, especially gender, ethnicity, and data practices, as I have mentioned. Collaborating is what we just discussed. Publication of and dissemination. Publication is absolutely essential for science. Questions about authorship, and if there are errors, we have to correct. Honestly, I mean, we have to recognize there are always corrections in our publications, so you can use it if they are honest. Negative results may be important also to publish, which may be difficult in journals. What are the acceptable research practices? As we say, for instance, here we have at least republishing substantial part of our results, or citing selectively. Here we have a number of violations of good scientific practices, which have to be, well, how to deal with that? When something happens, when something appears that someone has been violating some of these research practices. As I told you, there are research offices in many countries that have to deal with these questions. And this may be delicate, I mean, you see, because you are dealing with something that it's essential for instance, the personal reputation of the person. So you have to have procedures on that. They have to do it in a fair way. And as it says here at the end, anyone accused of racist misconduct is presumed innocent until proven otherwise. But this is maybe a very complex issue, but you have to deal with them when these things happen. So just to finish, I would like to give you some training tools. There are training tools on research ethics. For instance, there is the Embassy of Science that have a number of training aspects, especially for young people. The Austrian Office of Scientific Integrity has also a number of very clear ways to inform people and to train. And NEMBO, for instance, it has been very active in producing resources to foster research integrity. Thank you very much.
And we do thank you,
Mr. Voltinik, for all the information. It was quite complex, and it was really nice 101 to the ethics in science and integrity in research. Well, I can't see any questions right now, but I would like to ask something. Do you have any feedback on which level the implementation of the rules is within the different countries in Europe or within the different research institutes?
Well, as I told you, in Europe, different countries have different legal frameworks. They have different traditions. And some countries have produced, I just referred to Austria, but I mean also Finland or the United Kingdom, now France, have their own offices of research integrity. Institutions, many institutions I know in Germany, for instance, Max Planck or the FG, they have their own code of conduct. I know that, for instance, even private foundations, for instance, the Wellcome Trust or Nobel Nordis, they have different rules. That when they say that if they find that something happened very important, they will ask universities or research to bring money back. So also happening in Europe. So I mean, as I told you, I mean, for instance, in Denmark, that has a very long tradition of these questions, which they have a specific law and a specific legal committees. Every year there are a number of cases that they deal with. So the question is that, of course, we have the rules, we have that, and it's very important that everyone it's aware of that. In Europe, for instance, the European Research Council, it has their own rules, their own procedures to deal with these questions, which may be also very complicated to be analyzed in European context. So, but then you have to deal with these questions because the worst would be not to discuss and to hide what is happening. Dr. Clement would like to say something, please.
Yes, Professor Voltinik, thank you very much for your talk. It was very interesting and very invigorating. I would like to ask you about plagiarism. I think this is a big topic both in Czech Republic and Slovakia, from which I come from. And I would like to ask your experience or your opinion, because this is definitely a very important ethical topic for the reasons that you mentioned. But it is also a political topic, and it is being politicized. In fact, I was quite surprised when I was discussing the reform of university education in Slovakia. I learned that one of the pillars of the reform is basically enacting already two acts combating plagiarism as a pillar of reform of the system. I understand that this is a very important issue. So my question really is, what is your experience? Is it politicized also in other countries? And how important is this in the whole context of making the universities a better place for education?
You are completely right. Plagiarism has a number of consequences. I mean, if you produce something, I mean, our job for scientists, but also for artists, for instance, or for writers, for instance, no? Their product, their life is the product that you have produced. If someone appropriates your own product, it takes from you, it takes your own life, in fact, your own products. So this is very important. It is different in science, probably, that what is happening in literature or in music, where it has say commercial consequences. So there are in some countries you have to distinguish the plagiarism that has some commercial consequences from the plagiarism that has not. I mean, if someone plagiates a music and it sells this music, of course it has some commercial consequences. In science, normally it may not have that just with publish, but it can be as important. But I mean, you have to distinguish these cases. Plagiarism, it may be relatively easy to discover. Now we have softwares, we have ways. Many journals use these things, these ways, and of course it may. The discussion that I've seen in some countries is that, I mean, besides these cases that we have to deal in when I was chairman of the ethics committee of the Spanish Ethics Council, we had to deal with a very important case of someone who has just copied pieces exactly of other work. This is relatively easy to discover and to deal, you see. But of course, when you just cite some works of others, if you do it properly, that is the question. To not to just appropriate the text, the ideas, but to cite properly. Here, it can be some training needed. You see, how to just acknowledge that someone has said something, and you have to acknowledge properly. What you cannot say is to take these ideas to reproduce and to say that it's your own ways to do it. This is completely unacceptable. So, but I mean, you're completely right. It's an essential point for many cases. And we have also to recognize that in some cases, these things 10 years ago, 15 years ago, things were considered differently than they are today. It's difficult to judge a text that was produced 20 years ago with our point of view, right? You have to deal with all these questions. When they happen, normally either it's very clear, because plagiarism may be very clear, or in some cases it would need to be analyzed properly, and that may be also not so easy.
Thank you.
Yes, and the plagiarism
is also one of the issues for the next speaker. So thank you very much, Mr. Puigdominic and Mr. Clement. Thank you for your speech and for your questions and comments. And now we will have a pause for 3 minutes for the next speaker to get ready, and we will continue in 3 minutes. So see you soon. Welcome again to RICAIP Project Seminar focused on ethics in science. And it is my pleasure to welcome here the next speaker, Tomas Voltinik, who works as a lecturer at Masaryk University. He is specialized in theoretical informatics, cryptography, algorithms, and information technologies. His research interest is plagiarism detection, prevention, and academic integrity. This interest made him also a representative of the Czech Republic in the Pan-European Platform for Ethics, Transparency, and Integrity in Education at the Council of Europe. He has been involved in studying plagiarism and academic ethics since 2008, and he helped to set plagiarism detection system at Mendel University in Brno. He is also a chairman of the European Network for Academic Integrity. And this all makes him a good person for providing us examples of specific cases and their consequences, namely for the trust in science. He will discuss the causes of academic misconduct and measures that can be implemented to prevent it. Tomáš, the floor is yours.
Thank you very much for a very nice introduction. I would like to go to the next slide. Oh yeah. So you basically mentioned all my background. Yeah. So I have been involved in several projects that were focused on plagiarism, and namely for policies of plagiarism. The projects that were funded by the Council of Europe, and later served as a basis for the recommendation to member states of the Council of Europe, which is now being drafted and it's almost finalized, the recommendations on combating the fraud in education. This presentation draws from my experience in this project, in these projects, and I have to say that my main integrity issue is plagiarism, and I'm more interested in educational integrity rather than scientific integrity. But as we know, in academia, education and science are interconnected. So even though the issues might be slightly different and the ways how to address these issues might be slightly different, the basic principles are the same. So what I'm going to talk about, I will briefly talk about three cardinal sins in science: fabrication, falsification, and plagiarism. I will talk about consequences and causes of scientific misconduct and how can we prevent these types of misconduct. And as a main preventative measure, I will talk about building a culture of academic integrity. First, to clarify the terminology, so throughout this lecture, whenever I say academic, I mean educational and research. In academia, education goes hand in hand in research, so I perceive research integrity as a subset of academic integrity as well as educational integrity. And also, from the negative point of view, academic misconduct involves educational misconduct and research misconduct. The terminology is not really clear. Some people perceive it in another way. So academic is often perceived as educational only, putting research integrity on research misconduct aside. But I understand this both research and educational integrity as a subset of academic integrity. So just to make it clear. So what is academic integrity? When I want to explain, for example, to my friends what is my research topic, and I say academic integrity, they ask what it is about. So the easiest way for me to explain is that it is not cheating. So, and also when you go to news servers, to media, the negative approach is really typical. The perception that academic integrity is no exam cheating in education, no plagiarism, no scientific misconduct. It's how academic integrity is widely understood in society. And also, a reactive approach to academic integrity is quite typical. So when institutions want to deal with academic integrity, their main motivation or main approach is prevention of cheating, prevention of plagiarism, prevention of other forms of misconduct, and prevention of scandals. Let's stay for a while with this negative approach, and let me talk a bit about three cardinal sins which scientists may commit, known as FFP. The acronym stands for fabrication, falsification, and plagiarism. Textbook example of data fabrication is Diederik Steppel, former dean and professor of social psychology in Tilburg University in the Netherlands. The scandal happened some time ago, and there were some measures how the society, particularly scientific society, learned from this scandal. So this is the case which is used as an example. How can we explain the causes and the measures that were taken afterwards? Professor Steppel's methodology was developed through the time to the way that he always designed an experiment, designed the hypothesis, methods. It was a social psychology, so he relied on some questionnaires for people, and then pretended to conduct that experiment. But he actually never conducted such an experiment. He fabricated all data to support the hypothesis, and then published a nice paper, finished a nice project, and everything worked as he predicted. All the hypotheses that he said were proven. So the world was nice until his colleagues find some doubts and expressed these doubts publicly. And in 2011, it was a huge scandal when it that shocked the whole Netherlands. So the scientific community found out that it was all fraud, that he fabricated all the data. And it was not the problem of himself as a person. It was not a problem of his university. It was the huge scandal that led to loss of trust in scientific community and in science as a whole. But on the other hand, it was also the opportunity to set up processes that significantly improved quality of science. And now the Dutch institutions are leading all the efforts in the Europe to implement the codes of conduct and other measures to support scientific integrity. So this is example of data fabrication. The second cardinal sin is data falsification. I can take an example of an article of Wakefield 1998, which proved the connection between the hexa vaccine and autism. Later, this article was retracted because it was found out that the sample selection was biased. So if you take the sample selection when you have mainly the people with autism, so then it is easy to prove that whatever causes autism, and in this case it was the vaccine. The research, maybe in quotation marks, was founded by another company, by a competitor that was manufacturing alternative vaccine. But it took some time until that paper was retracted. So yeah, it took 12 years, and even though it is now 12 years, it has been now 12 years since the retraction, this paper is still alive on conspiracy servers, still fuels distrust in vaccination, and still I can say it's causing lives, because the parents who lose trust to vaccination, refuse to vaccine their children, and then the diseases which could be easily prevented spread in some communities. So again, we see that the case of scientific misconduct led to the loss of trust. And trust is something which is really crucial to science. Yeah, that the main purpose of science is to uncover the truth and to make advancement for the goodness of the society. And if the society doesn't trust the results of the science, then all the efforts of the scientists are wasted. And again, here we can see that it was not the consequence for the particular author or for the particular institution. The loss of trust affects whole sector. Plagiarism, there are well-known cases of plagiarism. German Minister of Defense Karl Theodor zu Guttenberg is probably the most famous case of plagiarizing politician. So he got his degree in 2007. 4 years later, there were some accusations from plagiarism. He first claimed that the allegations were absurd. Then he admitted some errors in footnotes. Well, the detailed analysis found that there were much more than some errors in footnotes. So after university withdrew his doctorates and more than 50,000 German academics called his resignation, he really resigned. And it was not the only case of plagiarizing politicians. There are more cases. Hungarian president, Romanian prime minister, Romanian minister of research and education. In Czechia, we have recent case of the minister of justice, and so on and so forth. US first lady, Kazakh vice minister. There are some doubts about the dissertation of Russian president, US vice president in that case. Now president in that time. Now President Joe Biden has also some case, and so on and so forth. Like basically every country has their plagiarists among the politicians. And again, what are the consequences? Romanian author Teodor Tudoroiu took the cases of famous politicians and examined how it affected the society. And he found out that citizens then perceive educational system as corrupt. All these scandals lower citizens' confidence in democratic structures and thus may represent aggressive threat against democracy. So this is his conclusion. I know that it's quite strong conclusion, but as we are talking about loss of trust, this is the consequence which loss of trust leads to. And we can generalize this to any form of misconduct. Any scandal leads to the loss of trust. It's not only plagiarism. So put these three cardinal sins together. Some researchers interested in research integrity were interested how often they happen and how severe they are. Lex Buter asked the participants of the World Conferences of Research Integrity and asked them about their subjective opinion about these three forms of misconduct, so fabrication, falsification, and plagiarism. And the result was that plagiarism is the most frequent one. The fabrication is less frequent than falsification, and then plagiarism is more frequent than these two. When it comes to severity, it's vice versa. Researchers perceive data fabrication as the most severe form of misconduct, whether plagiarism is less severe. Probably that's because we have the systems, so it is it might be easier to identify the plagiarism than fabrication or falsification. And also, if the plagiarism is only copy, it doesn't really affect the scientific truth, whether fabrication and falsification does. Let's now look at the causes. So, in general, causes of any like ethical misconduct are of three kinds and can be expressed as this triangle called fraud triangle. So first cause or first set of causes is pressure or motive. Pressure to finish a project by the deadline, pressure to get a grant, submit the grant application before the deadline, the culture of publish and perish, where researchers are evaluated based on the number of publications. So this creates the pressure to scientists, this creates the pressure to teachers at the universities, pressure to students. Then there is opportunity, or at least perceived opportunity. If there is no detection for plagiarism, then it is easy to copy and paste and publish plagiarized paper. And the third set of causes is rationalization. Like if the perception is that everybody is doing it, this is the common way how to do science, then it is easy to commit the misconduct. And also the risk-benefit assessment is part of the rationalization. So I know that I'm doing something wrong, but if the perceived benefit is larger than perceived risk, I may slip to do that misconduct. As I said, my primary interest is in plagiarism, and within the project that I have been involved in, we asked, why do students plagiarize? And we asked teachers, and we also asked students. What was interesting, we got completely different views from teachers and from students. If you ask teachers, why do students plagiarize? They tell you, okay, it's easy to cut and paste, so students are lazy, so they will plagiarize. They also think that plagiarism is not wrong, and they think that lecturers are as lazy as them and they won't care. But if you ask students, you get a completely different picture. The most common reason mentioned by students is that they run out of time, they are unable to cope with the workload, so again the pressure before the deadlines, and they think that their own work is not good enough, so they feel the lack of knowledge, that they don't know how to write it properly. When we map these reasons to the sides of the fraud triangle, so in case of students, we can see that it's mostly pressure, and then there is a rationalization. When the teacher's views emphasize the rationalization and the opportunity. So it is always important to take these differences into account, and when we want to solve some issue, we have to know what the real causes are. What are the causes of scientific misconduct? First of all, we have to admit that scientists are not different from other people. So there are always temptations for shortcuts, temptations for dishonesty. Like certain percentage of people tend to get their resources dishonestly, and this is unfortunately true for scientists as well. But that's not the only reason. David Goodstein did an analysis. What are the main causes of misconduct? And he identified career pressure. He also identified the perception that the scientists believed they knew the answer, so there were no need to actually perform the experiments. Like it's clear how it will, what the results will be. So why should I do the experiment and waste the time? And also, namely in natural sciences, where the experiments might be difficult to reproduce, this was the opportunity for data manipulation. And also, the very important reason, very important cause of scientific misconduct is lack of awareness of proper conduct, proper methodology, and some cases of misconduct happen unintentionally by the lack of knowledge. So who to blame? If there is any problem, if there is any misconduct, either intentional or unintentional, should it be the primary responsibility of the research assistant who did not evaluate its statistical data properly, or who changed some images which was later identified as misconduct? Or is it the responsibility of principal investigator who has the responsibility for the whole project? Is it the responsibility of all co-authors of a paper where this was published, because the publication guideline says that all co-authors have the responsibility for everything that is mentioned in a paper? Or the whole research group, even the colleagues who were not directly involved that, but had the opportunity to see that something wrong is happening and did not do anything against that? Head of the department who did not do proper oversight of his subordinates? Or the whole institution who perhaps did not set the processes properly? Or is it the fault of the whole system which distributes the resources based on the number of publications and thus creates the environment of pressure? The answer is not really clear, and I would say that we should blame all of them, or at least all these stakeholders take part of responsibility, at least because they will be affected by the consequences. If the society lost trust in science, it will be the problem of whole system, and it will be the problem of every single scientist because of the lack of funding, lack of trust, and so on. So how can institutions deal with it? Let's go back to Diederik Steppel's case in the Netherlands. Klaas Sietsma, who was his vice dean and then stepped in as an interim dean during the scandal, described this in his keynote address at World Conference of Research Integrity in 2017. And he described what interventions the university adopted to prevent these scandals in future. So they introduced a measure that each PhD student has at least 2 supervisors instead of 1, to have independent check that everything is going properly. All the theses are now scanned for plagiarism, which is also standard in many institutions. Then there are some psychological interventions. Official formula is read aloud publicly when doctorate is awarded. There is code of conduct, and every staff member has to sign this code of conduct and commit to follow that code of conduct. And they also introduced an independent integrity officer and research committee, so anyone who has some doubts has a place to approach. And what, in my opinion, is particularly interesting, that they introduced annual audit. There is an audit committee who every year randomly selects 20 out of circa 500 papers. They go to the researchers and audits all the data and the methodology, ask for the raw data, try to reproduce the experiment if there were some scripts run with the data, they want to rerun the scripts and so on. And then they do provide some advice to researchers and to management. The aim of this audit is to improve accountability. It was difficult at the beginning to persuade the community that it was not a witch hunt, but it was an opportunity to learn. And there at the beginning, the researchers were quite hesitant. Why are you checking everything? I am not a fraudster. I did everything properly. But then they figured out that if there is a risk that someone comes to check everything, it inherently lead people to more precise procedures. They take more precise track about the methodology, and it increased accountability, increased responsibility, reproducibility, and contributed to better policies at that institution. But the important thing is that they persuaded scientists that it is not a witch hunt, but it is the measure that aims to improve quality. So back to the fraud triangle, we have to lower the opportunity, these deterrent strategies, text matching software for plagiarism detection. We have to lower the pressure, which is easy to say but difficult to implement because of the external pressures for funding. But if the institution emphasizes intrinsic motivation for the quality of science rather than the extrinsic motivation for the quantity of papers, that is something that helps. And also lower the rationalization, move the perception from like everybody is doing something wrong to nobody is doing. This is something that we don't accept at our institution, which is known as a culture of academic integrity. It is not something that you can do overnight, that you can implement by one measure. It requires systemic effort, but the examples from scientific literature about the systemic effort for plagiarism prevention show that this works, and it works quite well. Here are two examples from an Australian universities who wanted to prevent plagiarism, and they introduced a number of measures. They introduced text matching software, they introduced courses on academic writing to teach the students how to write properly, and they implemented larger educational changes. And all forms of plagiarism dropped significantly at both institutions. So the general findings from these studies are that it is always longitudinal strategy. It has to it requires like all stakeholders, commitment of all stakeholders, and a lot of effort and a lot of funding is needed. So in education, there is central role of assessment, and they are addressing both educational approaches to teach students, to motivate them, and also deterrent strategies to prevent and detect misconduct. This is something that can be transferred to scientific integrity as well. Address education to prevent unintentional misconduct, and deterrence to prevent and detect intentional misconduct. So back to academic integrity, and now let me to define academic integrity positively. So not as not cheating, not plagiarism, not fabrication or falsification. I can like compare it to like happy relationship between two people or happy marriage. It would not be enough if there is no cheating. It would not be enough if a husband does not beat her wife and does not spend all the money for cigarettes and alcohol. Yeah, this is simply not enough. We have to have some like mutual understanding, trust, and these positive values. And the same is true for academic integrity. So if you want to define what academic integrity is, rather than what it isn't, it is compliance with ethical and professional principles, standards, and practices that are performed both by individuals and institutions in education, research, and scholarship. And then the culture of academic integrity is individual, group, and institutional behaviors, values, beliefs, attitudes, and characteristics that are promoting and following academic integrity. And academic integrity is a crucial presumption for quality of education and quality of research. It's something that has to be fulfilled. Otherwise, we can't talk about quality. Like integrity is not it's not enough as such. Of course, there has to be quality research and quality teaching, but without integrity, there can't be quality. I know that the previous speaker talked about some resources, so let me also offer some examples of educational resources. I will talk about the resources of the European Network for Academic Integrity, so the resources which I was involved in. So if you go to academicintegrity.eu, you can find the large collection of educational materials. There is glossary for academic integrity in multiple languages. There are general guidelines for academic integrity and self-evaluation tools, self-evaluation tests for students, teachers, researchers, and also institutions. Everything is available from the NI webpage, and you can also subscribe to a regular newsletter. There have been some Horizon 2020 projects on research integrity, Path to Integrity, which tries to connect formal and informal methods of education. They do some awareness-raising campaigns, the discussions, organize webinars and training events. The Embassy of Good Science provides the large database of educational resources for scientists and for management. There is also a list of certified integrity trainers. So if your institution wants to do some training, you can find the people who are trained to do that. And also the project Integrity that published a blog and also other resources. And I will finish my presentation to conference invitation, European Conference on Academic Integrity and Plagiarism, that is organized by University of Porto and European Network for Academic Integrity in May this year, both online and in person. And we have famous keynote speakers there. Teddy Fishman from the United States, Daniel Fanelli and Anna Marušić are well known in research integrity community. So, and I'm not sure if the presentation will be available, so there are some sources that I used and that I cited throughout my presentation, and that's all from my side. So thank you very much for your attention, and I'm happy to answer the questions if there are any.
So thank you very much for your presentation, and let's check the questions, and there is a question. So I will ask, what do you think about moving from internal institutional ethical committees to third-party research integrity institutions like ORI for solving cases of scientific misconduct?
I know about these ideas and about these efforts, and the main added value of this approach is to make the investigations and the judgments about the cases more objective, because sometimes solving the case within the institution might be difficult, especially when the high-profile academic of that institution, like dean or rector, is involved. So these independent bodies may provide more objective view. On the other hand, there is always the risk. No measure is perfect. So if the environment is that the institutions compete, there might be the pressure from like competing institutions to to perceive or to judge the cases more severely than is necessary. But otherwise, if you are asking about my opinion, I think that this is a good idea because of objectivity.
There is another reaction. Great talk, thank you.
Thank you.
And a question. Why do students really plagiarize? Are the teachers right or the students themselves?
It depends. I think that the students are more right here. But it also depends what is the cultural environment and where, in which country you ask the students. I personally did some workshops on plagiarism, and we did these workshops in Balkan countries, in former Yugoslavia, and some students told us, well, unless there is like proper detection and severe penalties, we will always try to plagiarize. If I may cite one of the students, he said that cheating is in our blood. So only severe penalties would work. So in this case, like teachers are more right. But then 1 month later, I went to Germany to quite a good university, and I asked students like what would be the best preventative measures, and teachers and the students answered like education and support from the teachers. They have to tell us how to do that and motivate us and so on. And I was still waiting like for the sanctions for anything like the penalties, and they didn't even mention that. And so at the end I asked, and what about the penalties? And they, oh yeah, of course you need penalties, but it was not among the things that they come up with. So it depends on the culture environment.
And do you also think that there is a certain field of study that is more endangered by plagiarism, falsification, or fabrication, that is more inclinable?
I wouldn't say that it is a field of study. It's rather the educational approach. For example, the Anglo-Saxon educational approach is more prone to plagiarism because the grading heavily relies on individual assignments which the students are asked to perform at home. So the temptation for plagiarism clearly is there. In Czechia, where the grades are mostly depending on the exams, so the opportunity for plagiarism is quite lower. And also, if the assignments or theses are more practical, so there is the emphasis on the own experiments conducted by the students, this is something which is more complicated to copy. The chances are never zero, but if it is like theoretical work which can be conducted only from your computer, from your desk, and with the internet, the risk of plagiarism is higher.
We saw some examples of public personalities that have some issues with plagiarism. Once something like this is revealed, what is the best reaction?
What can I do if I
Did a mistake in my career somewhere in the past, and now someone sets the light on it? What should I do to do the best reaction?
I would say admit the mistake, if it is like real mistake, because we have seen that all these personalities at first denied the allegations, and also denied that the plagiarism is even a problem, which make them ridiculous in the eyes of scientific community, and then it's one of the reasons why the people have to resign. If I remember the case of the Czech Minister of Justice, the plagiarism in her thesis was not as bad compared, for example, to Karl Gutenberg, but the statement that she made afterwards like completely disqualified her from the position of Minister of Justice, and that was the reason why she had to resign. So I would say don't lie, don't make false statement, admit the mistake, and try to do what you can to overcome this mistake. Like, everybody can make a mistake, and most of the mistakes that you can make in science should not disqualify you from scientific career for the rest of your life. But what is important is the self-reflection, admit the mistake, and adopt, at least internally, some measures how to not commit the same mistake again.
So thank you very much. I think these are good final words of your presentation. So thank you for your insights. And now we have another 5 minutes for us to have a break and then to move to the very last speaker of today, that is Marty Clement, and he will speak about technology transfer and money. So see you in 5 minutes. Today's seminar focuses on ethics in science. Can tech transfer money corrupt science? How can we foresee and regulate ethical aspects of tech transfer? And what did the COVID do to Czech science from an ethical point of view? These are the questions for our last guest of today. Marty Clement is an expert in the field of public support, research and development funding, public procurement, intellectual property management and technology transfer. The lecturer has been dealing with this issue for more than 15 years and he is going to share his experience. So get ready for his talk. You can start, Mr. Clement.
Good morning, ladies and gentlemen, and thank you for allowing me to speak on this conference. Unfortunately, I think I have more questions than answers myself. I would like to say that in comparisons with my previous speakers, where I think in the area of research and publication, many of the moral or ethic issues have been clearly defined. In the sector of technology transfers, the whole subject is older because we are somewhere between the world of public or publicly funded research and development, universities and academia on one hand, and a sector of business, which is a quite a different world with different ethic rules, etc. Also, I'm in a different position because I myself am not a scientist nor a businessman that would be involved in technology transfer. I'm an advisor, and many of you are probably thinking, why on earth is an advisor preaching us on ethics, coming from one of the sectors which is not well known for ethics, which I think is true. So I think the problem of speaking about ethic rules in technology transfer is that I think these rules are much less clearly defined than in the sector of research and development and publications or teaching. So we need to ask ourselves, what are these rules that should apply to technology transfer, and what is their source? Also the point of view from legal perspective might be a bit different than from research and development perspective. So us as lawyers, we are being taught that ethics are rules which stand outside of the legal system. They can affect the legal system because many of the legal norms are defined by the rules of ethics. Some of them affect the way that the laws are interpreted. They affect the case law, and some of them are remained outside of the legal system, and there are just norms that are not codified, and they are either observed or they are not observed, and observing and not observing them has consequences that are not purely legal. And so if we are speaking about ethic rules, and we are talking about the fact that in the technology transfer, they are mostly not codified, there are no documents which would define a legal technology transfer, then we need to find the sources for such rules. And this is also a question because sometimes there are people who are lecturing ethics in science, and they tend to narrow the rules to certain sources of ethical or moral rules, which can stem from religious background or from literature, philosophy, or from some idea of a common ground of rules that we can all agree upon. Then also, we need to speak about what is technology transfer, because if I'm about to talk about ethics in technology transfer, I need to explain what I mean. So I think we could divide technology transfer in two big or many categories. One of them is saying that there is technology transfer, which could be called forms of commercialization, which means types of technology transfer which are made in the business sector in order to, first of all, transfer technology to the practical use, but also to get some money out of it, to earn some economic benefits. And the typical transactions in this category are mostly licensing or creation of spin-off companies, or providing services, advisory, or other, or even producing some technology ourselves within the university or academic sector. And then we have a broader definition, which has a broader scope outside of commercialization, where as technology transfer, also other activities are considered. Some of them were mentioned. For example, publication can be deemed a transfer of technology into practical life. Also mobility of people between and within, between the sectors and within the sectors, and various other activities. As I said, transfer of technology is a meeting point between two worlds, between the academic sector and the business sector. In my experience, even though we heard a lot of criticism and a lot of cases which were subject to public criticism, is that I would say that in the academic sector, I have met with a lot of people with a very strong scientific integrity and more integrity, whereas in the business sector, one could say either that there is less ethical integrity, or that there are various environments which have their own rules of what is ethical and what is not. So how does ethics impact technology transfer? Because if we say that there are certain rules which also apply to the ways in which we transfer technologies into practical life, we need to speak or discuss how this can positively or negatively affect this area of activities. I think probably the most important factor, and this is also common with the ethics that has been discussed in the previous talks, is the effect on the reputation of the institutions which are undertaking the transfer of technologies. There are various aspects to it. Goodwill is something that can be established in the value of money. So it's a special category. A certain university has a certain value that's associated with its name, and good transfer may increase this goodwill of such institution, and bad transfer may substantially harm the goodwill of such institution. This can result in less access to funding, in political criticism. It can have the impact of demotivating students to study at such institution. It can have a negative impact on employment policy, because sometimes the result may be that people just don't want to work on such institution. It has also impact on the atmosphere within such institution, within a research organization, or between the research organization and the partner. And of course, it has impact on people's psychology and conscience, because I think it's one of the greatest fears of any scientist is that their technology can be used for bad purposes. So this is just an introduction on how I understand the topic. I would like to ask the present colleagues and speakers if they agree or have a different view on the general assessment of this topic.
I agree.
Thank you for joining in, Dr. Voltinik. Yes, probably that sums it all up. So the first topic, if you could stay with me, and thank you for joining, is the question of technology transfer and money. This is definitely an important issue, and I want to basically share my experience with this topic. So there's this general challenge, I think, for the whole of Europe. I hope you would agree with me that somehow we are relatively very good at brilliant research and publication, but the problem is that where we fail compared with other states is that sometimes we are not so good at implementing these brilliant ideas into practical life. In short, to transfer the technologies into practical life. I think this has different reasons, most of which are based on tradition. And during my 15 years of experience, I see a great shift in the whole viewing of technology transfer. At the beginning, my prevailing experience was from researchers that technology transfer is something ethically problematic in itself, that the most ethical activity is just, let's say, basic research-oriented research, and that the technology transfer is something that the bad people are concerned with. And there's a strong shift, I think, in Czech Republic, in my experience, where this is also a generational shift, where younger researchers view technology transfer as something that's integral to the whole scope of research and development activities, and an important part. And with it, hand in hand, comes the question of money. How important is money in technology transfer? I myself am very often involved in different tech transfer studies, which analyze specific projects from different, usually economic points of view. Very often, I must admit that the ethical issues are not stressed enough, I would say. And some of the ethic issues are somehow hidden within the economical assessment. So most tech transfer projects have a part which is discussing purely financial gain from the transfer projects, which is usually an Excel table which somehow sums up the possible financial gains from the project, and side by side with it is a broader economic analysis which speaks about other benefits of the specific tech transfer project, which is, for example, the impact on economy, employment, environment, health, etc. And I must say that when these documents are assessed, and this is surprising for me, the stress is often put on the money itself. So we as advisors are often pushed to emphasize the monetary aspects of the tech transfer project. And what I try to do in my work is trying to put an emphasis on the different aspects of tech transfer. So that's one point. Financial versus non-financial aspects in technology transfer, and how to argue, and which is more important. And then there's this other issue, which I think is also very important. how much money should we ask for our technologies? How much focus should we be on that? How much money should we distribute between the researchers, the inventors and authors, and how much money should be paid to the institution? And also, is it bad if we earn money on technologies, or is it an internal part of technology transfer? Sometimes there is this idea that we should transfer for market prices, which is something that's very hard to define in technology transfer. So these questions of how important is it that we earn a certain amount of money for a license sold to a patent, or to some kind of design or anything, versus the other aspects of putting the technology to work, helping certain people, helping the environment, etc., etc. How to approach this? How to compare these factors? That's basically a question that I'm asking, rather than a statement which I would be able to formulate as an answer. Would you comment on these topics?
If I may step in, yeah, I would like to comment on the topic of ethicality of technology transfer. That you said that some people perceive technology transfer as unethical. I would maybe put it like other way around. I would perceive as unethical to do science that is not transferable to do some good for society, because that's the main reason we have science here. So what are like, why should we produce the results which are not transferable to to any goodness for the society? I know that for the fundamental, for the basic research, it's complicated, and then the avenues are not like straightforward. So the technology transfer is not there the straightforward. But like all the science that is done, in my opinion, should be done with the view that it increases the quality of life of people.
Yes, you are very right. Also, somebody says that we shouldn't use the word technology transfer, because then we are limiting the issue of transferring the results of science to technically oriented branches of science, and we are forgetting social sciences and different branches of science that wouldn't be included in the term, or their results wouldn't be included in the term of technology. So how bad is it if a scientist gets rich from a certain technology? I will tell an anecdote. In Czech Republic, we have a famous scientist, Professor Holý, which used on the Institute of Biochemics in Prague. He invented a cure for various diseases. And what I heard as a story is that when he died, the institute asked his wife, where should we send you all that money that these patents are still earning? And what was revealed, that his family didn't know that he's a rich person. And only after he died, his wife, when she went to cleaning service, that she found in his pockets receipts or account numbers where he stored the money from his research. Also, there's a big discussion, because most universities and academia, at least in Czech Republic, have a motivation system which is aimed at providing the scientists, and they are entitled to this from patent laws, to have certain financial benefits from the inventions that they make at universities and other research organizations. So the question that I think is on the table is how much profit should go to the inventor, and to what extent is it ethical, and when does it stop to be ethical?
Well, from the point of view of labor law, if you do some work as a part of your employment, so the results belong to your employer. So then it should be up to the institution what to do with that money that come from the technology transfer. But also then we get to the question of motivation. So it's not like black and white, and I would say that the most important thing is to have all these issues clarified before the project actually starts, because afterwards it's always biased by the potential gains of the stakeholders.
Mm-hmm. Yeah, I couldn't agree more. There's usually a method which is progressive, which under the rules of the institution, in the first stages of technology transfer, more money is awarded to the inventor, to the author of the technology, or to his team, and then as the income rises, the ratio is reduced, and the institution gets more money. I would like to stress that sometimes the financial aspects of the technology transfer are it is too much focus is put on them. I think what we should realize is that in many areas, sometimes it is more important that the technology gets into use than how much money the institution earns on the particular patent or invention or different kind of result. So that's one topic that I wanted to discuss, and thank you for joining in. The other question, I think, which is also very interesting, is the ethical versus non-ethical uses of technology in practical life and in business. I think most scientists find like one of their goals or biggest awards in science is probably the Nobel Prize. And most of the scientists also know that Nobel Prize is basically connected with the question of ethics and use in technology, because Alfred Nobel, the inventor of dynamite, if I can simplify it, is one of the examples of a scientist which makes an invention, and during his life finds that the invention wasn't used for the purposes he intended, but it was used for bad purposes, for war. And then we are getting back to the issue of money. This technology earns him a lot of money, and what he does in the end is that in his will, he dedicates this money for furthering research and development and the science, and somehow tries to reconciliate or heal his bad conscience as a scientist. And I think one of the major ethical questions which are very often overlooked is the ethical use of technology. I think my experience is in the Czech Republic that we have very little technology transfer projects, and if we are successful, if there's a success on horizon, and we see a commercial partner that's interested in some technology, wants to invest in the technology, then we are maybe a bit too eager to proceed with the project, and we might try to think back and try to self-regulate the uses of such technology. And I think there are two, from my point of view, there are two interesting questions. The first is, what are the good and the bad uses of technology? How to approach the question whether such and such use of technology is ethical or non-ethical. And the other question for me is practical, is to how to regulate such thing. because when we look at the first question, I think there are some easy or easier decisions to be made, where we differentiate between the military or war or non-war use of a certain technology as a one deciding moment, or who is the person that we are selling the technology. Are we selling it to someone we know or someone we don't know? Are we selling it to businesses in our countries, or are we perhaps selling it to businesses that might be connected with terrorist organizations or states which support non-democratic states, which violate human rights, etc. So that's one level of questioning. And then how can we safeguard it? If we get back to Alfred Nobel, had he imagined that dynamite would be used in wars? Was there a legal mechanism or a way to prevent such use of the technology? I would like to welcome Professor Pichdomenek to join us, because I would also like to know his opinions on these subjects. Would you like to comment on these issues from ethical point of view? Is there a way to identify good and bad uses of technology, and are there ways to prevent the bad uses?
This is something that the European Commission in particular has tried to discuss. I mean, there have been different projects in Europe that also have been devoted to these questions. One of the tools that have been devoted is what is called RRI, there's Responsible Research and Innovation, which, I mean, it's a tool to think about this kind of uses. You are completely right, this is an important. In my opinion, this is very difficult. This is very difficult. Why it is difficult? Because some technologies may be devoted to some kind of solutions of social solution, but then they find other types of solutions. How can we foresee all these developments? In my opinion, this is very difficult, if not impossible. But so I don't think that it's, I mean, in my opinion, and also the perception of society is changing. You see, for instance, now we are facing, which could be a possible problem with food supply due to the war. So people are asking to lower some requirements for environmental regulation of agricultural production, for instance. Yeah, just an example. But in the uses of telecommunications, for instance, it was completely unpredictable. Some uses. I mean, so I don't think so. I think that we have to always be keep an eye on what is happening, trying to look for the developments and possible consequences. And I mean, I don't think that we can avoid, as a scientist, to be all the time trying to respond to the questions that the society is asking to us, and to. So I mean, it's I personally believe more in a continuous, you see, a continuous way of alerting society, discussing with people, with politicians, for deciders, and then to advise them how to use these technologies. It's my opinion.
Dr. Voltinik, like to join us in this topic?
Yeah, I want to say that like any tool has a potential to be misused. So I believe that scientists should not be stressed much by this threat, because imagine the knife, like everybody uses it in a kitchen, and it's a definitely beneficial tool. And it can be used also for the murder, but it doesn't mean that we should not develop better knives. And also, I would like to add that it's sometimes vice versa, that the tools or technologies that were originally developed for warship are largely beneficial for the society. Like internet, it was designed for the military communication in US Army, or GPS was designed to have more precise weapons. And now the whole society is benefiting from these technologies. So this is something that is on the other side of the wave. So if there are some advances or some developments that are misused, we can always say that there are some technologies originally designed for killing people who are used in a beneficial way.
Yes, thank you. I couldn't agree more. There is also a provocative thought in my head that we have this strong competition in technology transfer in some countries like China or United States. And we are asking ourselves, why are they better at transferring technology into real life than we are? And the question that I have is that there are stricter ethical standards in Europe in some areas, for example, with regards to genetical modification, with regards to pharmaceutical products, etc. Whether, you know, this is a strange situation where we are competing with them, but we are applying different ethical standards on technology transfer.
Well, I don't think that we should blame ethics. I think that we have to think about. I mean, I've been in several ethics committees, probably yourself, and I think that we, from this kind of ethical reflection, I think we should try to avoid always to limit, to say no. I mean, it's the best thing would be to orient, to see how these new technologies can be used in the best possible way. So I don't think that all ethical reflection should be to put barriers, to put something. No, I mean, that from a point of view is a mistake, because complete barriers afterwards, they have some indirect effects, as you are saying yourself. No? Other people are using and they don't care. So I think that if it is so, that our standards, I mean, our standards should be well-funded. Well, I mean, for instance, safety standards in pharmaceuticals, in food, in all these questions that we have in many technological uses. I think that are very important that we have the best possible safety standards, but everyone should be clear, well-funded, that really are safety standards, as not ways of hiding competitor struggles or something like that. No, I mean, and we have a duty, because in Europe maybe we have been putting rules for everything, and some of these rules are not well. They don't have a clear reason for that. It's just, you see, because we have a precautionary principle that should guide us for everything. We have to think about. We have to think about the proper use and all these things. I think that one of the questions of in some countries, you see, probably the same question you are asking in Czechia is the same we are asking in Spain or in other countries about technology transfer. At least my experience is that people are now in academia, in many are ready to have new spin-off companies, to collaborate, to make contracts. but the scientific community in my country is small and it's underfunded, you see, and probably the same thing in your country. If you have a small community, this community is not well funded. If your community has to struggle, how can be competitive, you see, if we have bureaucratic rules that make us difficult to work in everything, you see. So I think that we have to look first to our own, the way that we do science in our countries, and try to solve that, to convince our society and our governments that science is essential for democracy, as someone has said, and is essential for our society.
Thank you. I couldn't agree more. Dr. Voltinik, would you like to add anything to this?
Yeah, maybe answer the question that you raised, if we should blame the ethical standards for this drawback. I don't think we should blame ethical standards as such, but if there is something to blame, it should be the implementation of the standards, because one thing to implement the standards to make them beneficial for the institution and to increase the quality. And of course, like any measure, you can over-implement and create it to the obstacle. And this is something that should not happen. Yeah, the ethical standards should be an obstacle to unethical behavior, but not an obstacle to like ethical and beneficial use of the scientific results.
I agree. My point wasn't to blame the ethics. I just wanted to raise the question that sometimes the competition is stronger because they have less regulation. And I'm not saying that we should lower our regulation. That was not my point. But thank you anyway. So as you see, these are difficult questions that are not so easy to regulate. I myself sometimes write license agreements, and I always try to put some provisions into those agreements which allow us as a licensing party of the technology to have a word in a way how the technology is used, to have a chance to withdraw from the contract if the license is used, for example, in connection with some problematic subjects, or if it tends to a use that's that it can affect us negatively, our goodwill and things like that. But of course, this is also not an easy discipline. So that thing covered. I would like to talk briefly as an ending to my presentation to an interesting aspect, at least for me, of technology transfer during COVID. I would like to hear your opinion on it, but I think in Czech Republic, the science has made a very good job in helping the state in overcoming the COVID crisis, which I think helped the Czech science in a way. For example, following the COVID crisis, there's this project of an virology institute in the Czech Republic, which would focus on the research of transferable diseases, and also I think there is a certain moral high ground that the Czech science has gained by showing that it's ready to respond to the needs created by such crisis. I myself have helped create and operate several companies that were created within the academic sector, which were focused on protective tools and testing, etc., etc. And what was important for me was a certain shift in the perception of these activities. I don't know if you encountered this as well, and I would like to hear your opinions. But these are basically ethical considerations, because I think at the start, when there was lack of protective tools and lack of testing capacity. Many of these endeavors were basically perceived as something exclusively positive. But as the time went and the crisis has neared an end, and some of these endeavors were perceived in a way which could be characterized by a sentence, "Oh, you are earning money on COVID." And some of the academic people involved in these activities even try to distance themselves from these technology transfer activities. So this, at least in Czech Republic, was an interesting, because we were discussing that the topic of money and technology transfer of the problematic of defining what is ethical use and what is not. And I think the COVID crisis showed us that even over time, these perceptions can change. Do you have the same experience and or some different view or perspective on this topic?
Well, I think that there are a lot of lessons to be learned from the crisis, no? Not only about our system, our health systems in our countries, about how to deal with global crises. So, and of course, as you said, I mean, finally, the development of diagnosis needed new technologies, new vaccines were completely new. People realized that. That does not, I mean, prevent that scientific community, I think in all countries, have reacted. Well, some people tried to gain some popularity, and you see that it did not help too much. The uncertainty was so high, you see, especially at the beginning, that to transfer to people that we were dealing with a completely unknown type of a virus that may react in different ways. And so I think that was difficult. And in this situation, the media had also a mixed type of reaction. We have to think about all these things, no? About our health system, about how to deal with global crisis, how to we have this relation with the scientific community and the medical community with the media, no? How to transmit this uncertainty, no? We have to learn a lot of lessons on that. But I think the final situation, I mean, I suppose many people realize that it was research that was essential for going out of the crisis and to understand and going out of the crisis. So I think that from this point of view, well, I think in general in Europe, ethical standards were not lower. So all the treatments were supervised by EMA in a in the past, but not lowering the standards. That was very important, I think. Yeah.
Yes, I agree, and maybe over time this perception will change and fix on a more objective way. Dr. Voltinik, would you like to add something to that?
I was just remembering the discrepancies between what scientists proposed and what were the predictions, and then the actions of the government. I think that this is pretty similar in other countries as well. And it also emphasizes the need for scientists to be able to defend and to explain their conclusion, and it's also part of I would say part of ethical standards. So not only to come up with some finding, but to be able to sell it, to explain it to the general public, because it then increases the chances that these findings will be accepted and actually transferred to practice.
Yeah, it's a very good point in the whole tumult of communication and miscommunication. It has become clear that's one of the definite lessons learned, as also Professor Pizomenet said, that this is something that we learned, that we need to communicate, and we need to be able to communicate the findings and the results of the science in each particular case. Thank you. So from my point of view, this is everything that I wanted to share with you today. I'm sorry that it's more questions than answers, but I think really this is one of the opportunities that stand before us as technology transfer develops, at least in Czech Republic, to not to forget the ethical issues and try to regulate or self-regulate these so that we are successful in our technology transfer, and we maintain the reputation of the academic sector.
Okay, thank you very much,
Mr. Clement. There is just one comment that is associated with one of the points that have already been discussed, but I just want it to be heard. There is a need for certain fundamental research that has no immediate use to be good for anyone. The inverse, do no evil, is certainly true. So this is just one of the comments that appeared here on Mentimeters. So thank you very much, gentlemen. This was maybe more than a lecture, a panel discussion of all three speakers of today. So let's clap our hands, at least symbolically, for our speakers, Pere Puš-Dominik, Tomas Voltinik, and Marty Clement. I think that we all have a lot to think about. So this is all about ethics in science for now. We hope that we have provided you some interesting insights and clues how to be even more ethical while pushing the limits of knowledge and technologies further. This seminar would not be possible without the support of RICAIP project. That is a project that focuses on solutions for distributed manufacturing in the Industry 4.0 environment. And it is also a team of RICAIP that tries to meet the highest standards of research integrity. And this seminar would not be possible without the information and nice advice that was given by our speakers. So once again, thank you very much, gentlemen, for joining us today and for sharing your experience and your knowledge. We would also like to thank you who watched us today. The whole session will be online, so if you would like to watch again or if you would like to share it with your colleagues, feel free to do so. It will be available on the YouTube of the RICAIP project. And this was not the very first RICAIP project seminar, it was the fourth one. So if you would like to go back and you would like to watch some of the previous seminars that were on topics such as smart cities, smart districts, smart region, or how to be more inclusive in science and tech fields, and how to be more open towards our colleagues in science and towards the general public, you can go to RICAIP project channels and see the recording of the previous seminars. This was the first seminar of 2022 season, and it was not the last one. So if you would like to keep in touch, you can follow us. You can follow the CEITEC social media on Twitter, LinkedIn, Instagram, Facebook, or you can also follow the RICAIP project. And there, details about next seminar will be announced. So thank you very much for watching us, and I hope that you are encouraged to do better and more ethical science. So thank you very much again, and see you on next seminar of the RICAIP project. Have a nice day.